Good morning. Today we are going to talk about angles and the kind of properties that we can use with angles and how we can move them around and how we can use them to help us to solve different values for x. So the first thing that we need to talk about before we talk about what an angle is a geometric figure is called a ray if and only if it is a subset of a line with exactly one endpoint. Alright, so a ray has only one endpoint. So a ray might look like this. Draw an endpoint going off to infinity in one direction. So we'll call this point A, and we need another point to be able to identify a ray. A ray is never just one point. Alright, so you need to have 2 points. Remember again, a point is not an arrow. That's not the same thing. Okay, and we would label this. Remember we talked about labeling things. So we are starting with point A and going off into the direction. So this would be ray AB, and the arrow should point to the direction that the arrow is going. It's going off towards B to infinity. So a ray has a starting point here at A, but it's going off to infinity with the arrow. Another way you could label this would be to say BA, but that means that you would have to draw the arrow the other direction because it's going towards B. So I always like to start with the point, the end point, if you will. So I like this way better. Even if your ray is going the opposite direction, okay, even if the ray went this way, maybe this is A and this is B, I would still write AB with my arrow going like this, okay? It's a good habit to get into just to do it the same way. Alright, another example we could use, if we talk about a ray, let's go ahead and draw another ray over here, a longer one, and let's put a few more points. So let's call this point D, E, F, G. So if I were to label this ray, any ideas what we would label it as? Well, D is our starting point, okay? And some of you might say, well, we need to use G because G is the last point that we see. Okay, so DG would work. But also DE would work. The reason DE would work is because, remember, it's starting at D, going to E, but the arrow means it's going to continue to go. So it's going to continue to get all of the other points. So as long as you have DE as your starting, if you have D as your starting point, you can use any of the others. So we could say that this ray is also DF. All of these are a different way to label the same ray. Now what if I was talking about, just a second. What if I was talking about just this piece right here? If I was talking just only about that piece, that means I would be starting on FG. So I would say that this is ray FG if I was starting on F. Okay. So wherever your starting point is, that's the point you should start with when you're labeling. Alright? Okay, then we will say a geometric figure is an angle. So that's our next blank there. A geometric figure is an angle. If and only if it consists of two non-collinear rays with a common endpoint, which is called the vertex. Alright, so there's a couple things we need to talk about. First of all, this is the symbol for an angle. So it's a little, kind of like a less than sign with an arc through it. Now, you will see in your homework papers that they just use this as angle, but some students get in such a hurry that if they wanted to use angle L, alright, but they get into a hurry and so then it looks like this and I don't know what's going on. Alright, so instead of doing that, we're just always going to draw our angle symbol with the arc through it. Okay? Alright, so it says two non-collinear rays. Remember non-collinear? means that they're not on the same line. So I have this ray and I have this ray. They're going off in opposite directions, okay? And they have a common endpoint, which is called the vertex. So if I'm looking at this example, first of all, let's draw some points. That R should be a point, A should be a point, L should be a point, and then C is a point somewhere in the middle. All right, R is the vertex. It's the starting point that the rays meet at. This right here is the angle. This is what an angle is. It's the space in between these two rays. A lot of times students get to the end of the semester of geometry and still are not sure what an angle is. So I'm telling you, an angle is the space, this space in here, in between the two rays. That's what an angle is. Okay? Likewise, we could say that the interior of the angle is everything that's in here. So all this space in here is the interior of an angle. So if that's the interior, then that means that out here is the exterior. All right, so let's answer these questions over here on the right side. The vertex of the angle, remember vertex is the starting point. So the starting point is point R. R is going to be your vertex. The sides of the angle, well, we know we talked about two rays, right? So I have the ray over here. Oops. This ray and this ray. All right, so if I wanted to label those, I could say ray RA is one side, and the other side is ray RL. But how do we name this angle? How do we name this angle? An angle is named with 3 points. And with the 3 points, the vertex is always in the middle. All right, so remember we talked about the fact that in the middle, in here, this is the angle, right? So this is what makes up the angle. So I could say this is angle A, R, L. So A was here, down to R, out to L. That creates the angle. Another way you could say it is you could say angle L, R, A. You could go the other way, L to R to A. But notice each time R is in the middle, and that should always happen. Your vertex should always be in the middle of the two sides. Another way that you can name an angle is by using a number. So if you look here, this says number 1. That doesn't mean that that's the measure of the angle. That means it's just labeled as angle 1. Now that seems kind of like the cheating way to do it. Just put a number in there and you don't have to worry about the side measurements and all the letters. But I want you to get into the practice of using the letters, not just numbers, please. Because a number is not always going to be written there. All right, the measure of angle 1, if we wanted to figure out how many measure degrees, so an angle is measured in degrees, we have that written here, we would say the measure of angle 1, or the measure of angle ARL. Remember, with measuring segments, we just used italicized letters. We didn't draw a line above it. That meant measure. But to talk about an angle, you use a little m. Okay? All right, so that's an introduction to an angle. Let's go on down and let's do an example now. Okay, so in this example, the first thing that I need you to do is go ahead and make these points. So wherever you see letters, so this is point D, point C, point B, and point A. That didn't get copied onto your paper. Okay, if it says name the sides of angle 1. Well, angle 1 is here. Okay, so what are the sides that make that happen? Well, it's going to be this side and this side. So how do we name those sides? Think about that for a minute. Write something down and then we'll check to see if you have the same thing as me. Name the sides of angle 1. Well, we know that both of these sides are rays. Okay, so we could say ray DA and ray DB. Those are the sides of angle 1. All right, next problem says name the vertex of angle 3. So angle 3, go over here, that's this space over here, angle 3. The vertex, again, remember the vertex is the starting point. So the vertex of angle 3, or vertex is a point, would be point C. All right, and then it says name another name for angle ABD. So first we need to find out where is ABD. Well, I start at A, go down to B, oops, start at A, go down to B, and up to D. So I'm talking about this angle here. What's another way to name that angle? Well, yes, most of you are probably putting angle 2, which is correct. But another way, if we said ABD, we can just write it backwards and say angle DBA. That's another way to write that angle. Okay? All right, let's move on now. We're going to deal with some problems where we're going to need to put a couple angles together. Okay, so if we're going to put some angles together, if we're going to add them together, we need a rule that says we're allowed to add them together. And that rule is called the angle addition postulate. So you have angle addition postulate. An angle addition postulate just means that you can add angles together, 2 angles together to make a bigger one, or 3 angles together to make a bigger one. All right. Also note right above that it says the measure of an angle is a positive real number between 0 and 180. So an angle is going to be between 0 and 180 degrees. We will rarely deal with an angle that is above 180 degrees. Okay, so let's draw a picture of what this example says. It says if R is in the interior of angle PQS, then little plus little equals big. All right, so let's draw angle PQS. We know that Q is in the middle, so Q is my vertex. And I know that I have P somewhere out here. And S is also on my line. So we have angle PQS right here. And then it says R is somewhere in the middle, somewhere on the inside. Would you agree I could add this angle plus this angle and I would get the big angle, right? So if I told you the big angle was 60, for example, and that little symbol right there means degrees, if this angle was 60, and I told you that this one right here was 20, you would be able to say, okay, well 20 plus x equals 60, and we know that then x is 40, so that this angle would be 40 degrees. That's what this rule says that we're allowed to do. We're allowed to add 2 angles together to make the big one. All right? Okay, so now we have some types of angles that we're going to talk about, specific angles. We would say an angle is classified as an acute angle if its degrees are less than 90, so acute. And I like to remember that by saying it's a cute little angle. Okay, if it's less than 90. So that would be something that is like this. This angle is less than 90, and we'll talk about what 90 degrees looks like next. So an angle, if it is exactly 90 degrees, is called a right angle. And that would look like this. It makes like an L shape. And we always use that box to represent that it's 90 degrees. Okay, so you can never assume that it's 90 degrees. You have to know for a fact that it's 90 by seeing that box. You can't ever just put that in there unless you know for sure. So notice that an acute angle is smaller, this one is smaller than what a right angle would be. Okay, and then the last thing is an angle is called obtuse if it is between 90 and 180. So it's going to be greater than 90. So it might look something like this, because right here would be a right angle, right? We can see that a right angle, it's less than, so it's acute, and then down here it's greater than, so it's obtuse. Alright, we say that a ray is an angle bisector, and we're going to abbreviate angle by drawing the symbol. An angle bisector. Remember we talked about bisector in the last lesson? It cuts it in half. So the same thing is going to be true with an angle bisector. You can have a ray that goes through the middle of an angle bisector. It creates two congruent angles. So let's do this example down here. Let's look at that. It says, if BA and BC are opposite rays, then BF bisects angle CBE, and BD bisects angle ABE. Okay, so here's a problem where if you don't read the directions, you're not going to be able to do the problem. You're not going to know how to set it up. So let's look at this first. It says BF bisects angle CBE. Okay, so that means that BF bisects angle CBE, this angle right here, it bisects it. So if it bisects that, that means that angle 3 and angle 4 are the same measurement, right? So bisect cuts something in half. So I'm going to draw one pair of arcs that represent congruency. Remember yesterday or in the previous lesson we talked about if you have segment bars like this, that means that those segments are congruent. All right, so the same is going to be true with angles, except we draw arcs instead. So then the directions say not only that, but BD over here bisects angle ABE. So if BD bisects angle ABE, that means that angle 1 and angle 2 are also congruent. But we already have one set of hash marks or arcs, so we have to draw a second set. That means that angle 1 and 2 are different than angle 3 and 4. If we only drew one set of arcs for angle 1 and 2, that would mean that they would be the same as 1, 2, 3, and 4. Okay, so we have our drawing labeled before we even start the problem. Then the problem says angle EBF is 6x plus 4. So we're going to label our diagram. EBF is 6x plus 4. And then it says CBF, C, so some of you that are maybe having trouble labeling your angles, start at C, go into B, and out to F. So it's talking about angle 4, is 7x minus 2. And it says find measure of angle EBC. Well, the first thing is we have to deal with what we've been given. We marked them congruent, so if they are congruent, that means that their measures are equal. So we can set up 6x plus 4 equals 7x minus 2. Because we know that the two angles are congruent. So let's go ahead and solve this problem. Take a minute and solve this problem. I'll do it up here as you do it at your seat. So we should be getting x equals 6. Now, the problem didn't ask me to find x. It asked me to find measure of angle EBC. So EBC, E to B to C, is this full angle right here. Well, if I know what one of them is, I can say that since they're the same, this one, EBF, is the same as this one. And then I could add them together to make the big angle, right? We talked about little plus little equals big. So let's go ahead and plug in x into the 6x plus 4. So I said that x was 6. So 36 plus 4, 40. So that means that this angle over here is 40. And down here is also 40 because they're congruent. So I know that the measure of angle, this is showing your work, and I'm a big person when it talks about showing your work. I need you to show your work. 40 plus 40. So the measure of angle EBC is 80 degrees. Alright, I'm going to erase some of my stuff so that we can see the problem more clearly on example 2. Alright, example 2, we're going to use the same problem and the same directions that talk about things being congruent. It says measure of angle 1 is 4x plus 10 and measure of angle 2 is 5x. Alright, so the first thing that we need to do is label our angles. Okay, so measure of angle 1 is 4x plus 10 and measure of angle 2 is 5x. So again, we have marked these two angles to be congruent. So if they are congruent, that means their measures are equal. So we can set these equal to each other. Alright, so let's go ahead and do that over here. 4x plus 10 equals 5x. Alright, let's go ahead and solve. We get x to be 10. But notice they didn't ask for us to find x, they asked us to find measure of angle 2, so we can't just stop there. We know that the measure of angle 2 is 5x. So we can plug our value for x in. And the measure of angle 2 is 50 degrees. All right, I'm going to give you a few minutes to work on number 3. I want you to try it on your own, and then I'll come back and we'll work it together. Alright, so I hope that you were able to set them equal to each other. So 8y minus 14 equals 6y plus 2. Add 14. So you should get y equals 8. So y is 8, but again, we have to pay attention to what they asked us for. They asked us for the whole thing of ABE. So if they want ABE, that means I need to figure out how much angle 1 is and angle 2, and then I can add them together. So we find out that angle 1 or 2, it doesn't matter which one to start with. Maybe let's start with angle 2 because it's an addition problem, so that's going to be a little bit easier. 6y plus 2, but instead of y, I put in 8. So 48 plus 2 is 50. So that means that this angle up here, measure of angle 1, is 50. But if 1 is 50, then that means that angle 2 is 50. Alright, so we could say measure of angle ABE equals 2 times 50. So the measure of angle ABE is 100. Alright. Okay, it's time to work on some homework. Again, you can work with each other. Please make sure that you read the directions, because I don't want you to miss anything when you're reading the directions, okay?